Part B. Kirsty uses a spreadsheet to produce the following diagrams showing the probability distributions of the number of coconuts knocked off their stands for different values of n. So you can see we've got n is 6, 13 and 55. Those are just random numbers they've chosen to show. There's no particular reason why they chose 6 and 13 and 55. But we've got this binomial graph with a probability of 0.2 each time. Okay, so we have to describe two ways in which the distribution changes as n increases. There's lots of things that they would accept as good comments. Okay, so there's not any specific things that they're looking for you to get the marks. So you could say, there's lots of things. I'll go through all the things that they've talked about. As n increases, you get a shape that looks more like a normal distribution. And the feature of a normal distribution is it's symmetrical on either side. So even though it's not symmetrical in the whole width, if you just look at its individual shape there, it looks more symmetrical there than it did here. Okay, so the actual shape becomes more symmetrical. Okay, so you could phrase that as it becomes more bell-shaped or more like a normal distribution. You don't have to say as n increases because that's in the question. That's helpful. Okay. What could we say maybe about the mean, the average score? Even though it's not a result that we're supposed to sort of know, it's useful. The average score for a binomial is n times p. Okay, if you are going to succeed 0.2 of your attempts, you would expect 0.2 of 6 or 0.2 of 55 to be successes. Okay, now the p isn't changing, but the n's increasing, so that means the average score, the average number of successes are increasing. And that's visually basically where the peak is. Okay, so the peak there is at 1, then the peak looks like is at 2, then the peak looks like, gosh, can't really tell there, maybe somewhere around 12. But the average is increasing. Okay. But interestingly, the probability of the average is decreasing. So that was, highest point was at 0.4, then it was at maybe 0.27, then maybe it's about 0.13. So I'll say, but its probability is decreasing because there's more outcomes that can happen. Okay, when you have bigger n's, you have to share your total probability between more outcomes. Your graph does get more spread out. Here, your numbers are only really visible within sort of like the 0 to 3, roughly. Then you've got sort of 0 to 6 or 7. Then you've got sort of like 3 up to about 20. The spread of numbers is increasing. So we can say the variance or the standard deviation is increasing. So that's another way the distribution is changing. Okay. The most common score, so it could have been the average being the mean, or it could have been the mode, which is the highest column. Okay, that's increasing. Okay, so there's different things you can say. They would look at anything you wrote and see if it fitted into a sort of one of their potential comments. Okay, try and stick to fairly obvious things. Okay, don't get too complicated with these sorts of questions. All right, but they are tricky to know whether you've said the right thing. I do know that. If you wrote more than 2 things down, it wouldn't matter. They'll just look for anything you've written that looks valid, that looks good. So if the first thing you write doesn't gain a mark, that doesn't matter. They'll keep looking for two things that you have written that do gain marks.